AP Calculus AB, Unit 10-Day 5 office hours. So during the notes lesson for this, I helped you guys kind of set up these problems as far as drawing them. Directions said dx and dy, but it's dx or dy. We're just going to do the dishwasher method on this assignment. No shells. If you look at my solutions online, I probably have both techniques. And it's really just about setting them up. I would probably try and evaluate it on a calculator, see what you get. But if you want to work it out by hand, that's extra credit. Probably make some note at the top of your sheet reminding me that you earned extra credit so I don't accidentally just forget. So this one's rotated around the x-axis. So I draw a reflection of this half onto the other half and then draw a slice. If you want to get dishwashers, it's got to be perpendicular to the axis of rotation. And that's how you get it. So the volume of a single disk is just a short cylinder. It's a circle times the thickness, the height. It's pi r squared. And in this case, dx is the thickness. And then we're going to integrate it. So this isn't something to memorize. Circle times thickness. That's what you should look at it. It should make sense. Our limits are going to be 0 to 4 in the x direction. The radius right here, don't confuse this r with that r, is y top minus y bottom. It's a vertical length, and y bottom is just 0 this time. Sometimes it's not 0. So it's going to be y top. The y coordinate along the curve in terms of x is going to be x squared. I mean, you could write it like that first if you want, and then write it in terms of purely x. So you get pi 0 to 4 of x to the 4th dx. That's the setup. And so if we were to do it by hand, it's going to be x to the 5th over 5, 0 to 4, 4 to the 5th power. 4 times 64, 4 to the 3rd is 64. So 64 times 16, that should give us that. 24, okay, the 2 to 36 is 38. 0, 4, 6, 4, 12, 1024. 1024 pi over 5. If you want to start trying the shell method, I have the solutions, I think, on my online version. But you should get the same answer. Okay, next one. Volume of a solid. Region is y equals the square root of x. Top half sideways parabola. X equals 4, vertical line. And the y-axis, y equals 0 is this. So this is a region. I'm going to spin it around the y-axis. So what I do is I take these dots and I try and get the corners first, and then I connect them. And then I draw one slice somewhere just in the middle. And emphasize over here, this is where you should be getting all your dimensions from, all your limits. Don't use anything over here to set things up. This is just to help you visualize it. So again, nothing to memorize, nothing to look back. Just think about it. It's a circle with a thickness, gives you a cylinder, pi r squared dx. Or dy this time, because they're flat, right? So everything's gonna be y this time. And then we're gonna integrate, get them all. So this time we actually have a missing piece in the middle, so we're gonna have to subtract a smaller pi r squared dy. So we're gonna calculate the big disk, which will include the middle, and then subtract the middle disk from it. This is the big radius, and it's x right minus x left. X left is just 0 this time. So it's whatever the x coordinate is here, which is actually constant. It's just 4. You can just plug a number in. You guys can integrate that. Now we're going in the y direction, 0 to 2. 0 to 2. Slicing it gradually. And the other one's going to be 0, 2. Now the little radius is right here. It's x right minus x left. X left again is 0, but x right is right here. This x coordinate is x right for the little r. And it is, we want to get that x in terms of y. So it's going to be x equals y squared, right? So it's going to be y squared. That also gets squared again. I mean, this is good enough for setup. I mean, you could technically type that in your calculator, but it'd probably be worth it to make it a little easier to type in to your calculator. Or if you're going to do it by hand, you want to simplify it. So that's a little nicer. Now, if you're going to do it by hand, 16, the antiderivative of 16 is 16y. And the antiderivative of y to the fourth is y to the fifth over 5, 32. So plug 2 in here, we get 32 pi minus 0 minus pi 2 to the fifth, 30 to 8, 16, 32 over 5 minus 0. So we could give these guys the least common denominator, and it'd be 5. So multiply top and bottom by 5. So that's going to be 160 minus 32 is 128 pi over 5. And if you do it on your calculator, you should get the same thing as a decimal. So we do, if I do it on my calculator, do pi math 9 16 comma x comma 0 comma 2. We're putting x's for all the y's. Minus pi math 9 x to the fourth comma x comma 0 comma 2. And we get 80.424 or 80.425. Let's check 128 pi over 5. Same thing. Pretty nice. Okay. So let's keep going. This one's kind of funky. So this is actually the top half of a circle. This is the equation of a circle. Solve for y. We're going to rotate around the x-axis. And so this is our solid. I'm going to do one slice. If I want it to be dishwashers, I should slice perpendicular to the axis of rotation, straight into it. Emphasize up here, this is where you should be setting everything up, right? So the volume of a single disk is pi r squared, in this case dx, because it's a vertical slice. And then we're going to integrate all of them to add them all up. So our limits in the x direction, I guess we got to figure out how far this is. We could set this equal to 0 to find the x-intercepts. Square both sides. Square root of both sides, plus or minus, which actually makes sense here. Plus or minus is this is positive 3, and this is negative 3. So in the x direction, we're going to go negative 3 to positive 3, left to right, all the vertical slices. And this is our radius, which is y top minus y bottom. Y bottom this time is 0. But it's good to just keep thinking that way because sometimes it's not. Y top is just going to be the y coordinate along the top in terms of x, which we have right there, 9 minus x squared. But then it gets squared, which is really good. So that's your setup. And you can plug that in your calculator. We could easily simplify it a little bit for calculator, and especially by hand. Just going to be 9 minus x squared. Still need the parentheses. So that's a little better. If we're going to integrate it, antiderivative of 9 is 9x minus x cubed over 3, negative 3 to 3. Plug 3 in, we get 27 minus 27 over 3 is 9 minus negative 27 plus 9. So this is going to be 18. This is going to be minus negative 18. So that's going to be 36 pi. Now, this is a sphere. What we've created is a sphere, and the volume of a sphere, thanks to Archimedes, is 4/3 pi r cubed. And the radius of our sphere is 3. And so we get 27 over 3 is 9 times 4 is 36 pi. Same answer. Kind of cool, huh? That basic formula you've been using for years in geometry, we got the same answer using calculus. So on your calculator, you do pi. Don't forget to pi. People just forget pi. And you can just put it in front. Math 9. You can do pi first, then math 9. And then 9 minus x squared. I already squared the square root, just to make it easier to type in. Comma x, comma -3, comma 3. And we get 113.097 rounded truncated. Comes out the same. 36 pi is same thing. So it's kind of cool. You could check your answers, even the ones you do by hand. Okay, so this one, y equals x squared parabola. Y equals 4 is a horizontal line. So this is the original region, and we're spinning it around the x-axis. So I take the corners, and I transfer them, and I draw the other half, and I draw one slice vertical, perpendicular to the axis rotation. Turns out vertical this time. And this is going to be a washer method, which is really a big disk minus a small disk. So big disk is going to be pi r squared dx. And small disk is going to be pi little r squared dx. And I'm not memorizing that. It's a simple volume of a cylinder. Circle times a height. Then we're going to integrate them all. So the limits are going to be in the x direction, -2 to +2. And the big radius it's got to go all the way to the axis of rotation. So it's y top minus y bottom. Y bottom is 0. Y top is always 4, no matter what. Which kind of makes sense. The outer part of the shape is just a straight cylinder, right? And then the little radius is right here, and it's y top minus y bottom. And y bottom is 0. So y top is the y coordinate along the parabola. In terms of x is x squared. There you go. That's your setup. I mean, this would be good enough on a free response problem, the AP test. Now, if you're going to do it on your calculator, which you probably will, or by hand, it's going to make a lot of sense to clean it up. Right? I mean, this is a little nicer. Now, by hand, it's going to be 16x x to the 5th over 5. So that's going to be 32 minus -32 minus pi. That's going to be 32 fifths minus -32 fifths. Minus is plus 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 plus. So we get 64 pi minus 64 over 5 pi. So least common denominator would be 5. That'd be 320 minus 64 would be 256 pi over 5. So let's check our answer. Let's also practice just doing these on our calculator. We should be really good at these. Anytime we have the opportunity on a test to use a calculator, do the calculator. Just stop right there. So pi, math 9, 16, comma, x, comma, -2, comma, 2. That's the first one. So put an extra space there. Okay. Minus pi, math 9, x to the 4th, comma, x, comma, -2, comma, 2. And we get 160.849 or 160.850. 256 pi over 5 is same thing. All right. Okay, now these last two throw in a little extra challenge. The axis of rotation isn't going to be nicely on the x and y axes, which makes it a little simpler, makes one of the sides of your radius 0. But we're going to take the same approach here. So we're rotating around this vertical line x equals pi. So the first thing I do is I transfer these corners to equal distances on the other side and kind of quickly draw the other half. Draw a slice perpendicular to the axis of rotation to get disk washers. Okay? The volume of the big disk is pi r squared dy this time minus pi little r squared dy. The limits are going to be in the y direction. So we're going from 0 up to here. This is the top of the sine curve. Sine of pi over 2 is 1. So it's going to be 0 to 1. The big radius right here is x right minus x left. Now, x right is this coordinate here, pi. And x left is this x coordinate in terms of y. Now, x left over here, to solve for x, it's going to be inverse sine of y. That's the... So I don't think we're going to be able to do this one by hand. Inverse sine of y. Oh, wait, I messed up. Pi minus inverse sine of y, all squared. The inside, a little r, is going to be x right minus x left. And x right is pi, and x left is pi over 2 for a constant radius of pi over 2. If you look at this, the inside hole is a nice cylinder with a constant radius, pi over 2 squared. So this is your setup. You know, we could write it a little nicer. I don't think it's going to be worth it to FOIL this out. I don't think there's any benefit to that. This one right here, you could say, well, that's pi squared over 4. You know, I don't know. But we're not going to be able to integrate inverse sine by hand. We just can't do it. So I'm not going to do it by hand at all. You don't need to for extra credit. But let's see if we can get your calculator to integrate anything, because it's really using estimation techniques. So we got to put parentheses pi minus inverse sine of x, close, close, squared, comma x, comma 0, comma 1, minus pi, math 9, pi squared divided by 4, comma x, comma 0, comma 1. And we get 13.456. Now, if we had done shell method, we would actually be able to pull it off. And the answer from the shell method, which should be equal to this, is negative 2 pi plus 3 pi squared over 2. Negative 2 pi plus 3 pi squared over 2. Oh, that doesn't look good. That's a different answer. So either that one's wrong, or actually, you guys couldn't even do the shell method yet. In Calc BC, you could. Let me just double check my work real quick. And I feel like this is right. Pretty sure my setup is right. And did I type it incorrect? Let's see. So, I don't even know. Okay, let's just type it in again real quick. Pi, math 9, parentheses, pi minus inverse sine oops, and do that second sine, inverse sine of x, close, squared, comma, x, comma, 0, comma, 1, minus pi, math 9, pi squared over 4, comma, x, comma, 0, comma, 1. Takes a little longer for it to do this. I think we're right. So I don't know. This must be wrong. But okay. All right, last one. So you got to watch out for these shifted axis rotation. They're going to show up, in your radius. So this one's down here. I'm going to rotate around y equals 6. So the first thing I do is I draw the corners, connect them, draw a single slice perpendicular to the axis of rotation. Okay, and then we want to do all our work down here. So this is going to be a washer method, big disk minus a small disk to take out the middle. It's going to be pi big R squared dx. It's vertical slices, pi little r squared dx. And we'll accumulate all of them. The limits in the x direction are going to be 0 to 2. The big radius right here is y top minus y bottom. And that's from here to here. Y top is 6. Y bottom is the y coordinate down here in terms of x is x squared. 6 minus x squared squared. The little radius is going to be y top minus y bottom. And y top is going to be 6. And y bottom is going to be the y coordinate here, which is 4. So it's just going to be 2 squared. So there's your setup. If we're going to do it by hand, we're going to want to FOIL this out. 36 minus 12x squared plus x to the 4th dx minus pi 0 to 2 of 4 dx. The antiderivative is going to be 36x minus 12x to the 3rd divided by 3 plus x to the 5th over 5, 0 to 2, 4x, 0 to 2. So it's going to be a 4. So we plug 2 in and we get 72 minus 32 plus 32 fifths minus 0 minus 0 plus 0. And then we plug 2 in here, we get 8 minus 0. So now we just got to simplify it. So this is going to be 40. I guess we could give these guys the least common denominator, 5. This guy would want the least common denominator also, 5. So we get 232 minus 40 would be 192 pi over 5. Let's check it. Pi, math 9, parentheses 6 minus x squared, close parentheses squared, comma x, comma 0, comma 2, minus pi, math 9, 4, comma x, comma 0, comma 2, and we get 120.637. 192 pi over 5 is 120.637. Perfect. All right. So that's it. These, if you just do lots of these and really don't try and memorize any formulas, try and draw good pictures, understand the basics of the pictures, and then just get good at labeling your pictures and writing it down, and you should should be able to get really good at these. These should be very straightforward problems.